Right, we're going to tackle today indirect proofs. Now this is a proof by contradiction. To help you remember, if you recall, if we have a conditional statement, for instance, if P then Q, we know that the equivalent to that, in other words, it'd be equal to it, would be the contrapositive. If not P, then not, if not Q, then not P. This is the way we do a contrapositive. Remember, they were equal in value, in the truth value. So we're going to use that today to try to solve this problem right here using an indirect proof. The first thing is we have a scalene triangle of ABC. We also have two altitudes. Let's see if I can draw these altitudes on here. Right here, we'll call this. This looks like about a 90-degree angle from here. All right, that's one altitude, and we'll label this one E over here. And then I've got D over here. Let me see if I can get this in as best as I can. It looks like about a 90-degree angle. Comes right up about there, and we'll call that D. D. All right. Now we know that the first thing is that we know that let's start off here with the given. So I've got altitudes A, E, and C, D. So these are the two altitudes of this triangle ABC, which is scalene, which means that all three sides are different. So the first thing is I'll put down here my one is my given, which is triangle ABC is scalene, and AE and CD are altitudes. ALTITUDES. 1, okay, that's given. All right. Now I'm going to try to prove this right here. So I'm sorry that these right here are not equal. All right, sorry. I got to prove that these right here are not equal. So the first thing I do is I'm going to make the assumption that they are equal. So number 2, I'll make the assumption that AE, that the segment, these altitudes right here, are congruent, CD, and that's 2, and this is using my assumption. And essentially what I'm trying to do is use this assumption and do a contradiction, and then I'll have made an indirect proof. So I've made this assumption that these right here are true. So I will go ahead and make a mark here, and this right here are equal, okay? So now I know that angle B is congruent to itself, correct? So number 3, angle B is congruent to angle B because of 3, reflective. Oops, there you go. And I also know, since these right here are altitudes, that I'm going to put angle 1 here and angle 2 here, okay? And since these are 90-degree angles, since they're altitudes create 90-degree angles, I can say that number 4, that angle 1 is congruent to angle 2. And the reason I can say that, I know that altitudes are perpendicular, all right, to the opposite sides, right? And we know that perpendicular lines form 90-degree angles, which we know all 90-degree angles are congruent, okay? So that's kind of a little bit of, I could probably separate that into 2 steps, but we'll put it down here for 1. Now I've got an angle, side, so now I can put my triangle A, I'm going from ABE. ABE is going to be congruent to triangle CBD. Triangle CBD. Oops, of 5. And the reason for that I already mentioned is angle, side. So therefore, if I've got these two triangles right here are congruent, based on my assumption up here, then therefore AB is going to equal to BC, all right? So 5, 6. So AB AB is going to be congruent to CB, because the 6 of the corresponding parts of congruent triangles are congruent. Now, I know that I have created something that is false, right? Because I know that AB, so that means this right here would be the isosceles triangle. Therefore, I have formed a contradiction to what I was given. All right, so therefore, that being the case, then my assumption is faulty. So therefore, 7, I come back here that AE is going to be not congruent to CD, because that's the contradiction that we found on number 7. So, on step 6. So step 6 is contradiction, and therefore it's contradiction, to the given, all right? Because essentially what that is saying is that if these are equal, then it's an isosceles triangle. If this is not an isosceles triangle because it was given that it's a scalene, therefore, if that's the case, then I have to go back opposite to my assumption, and so the opposite of the assumption is true, which means that I'm back to here, that we have to using an indirect proof to prove this statement right here that these are not equal in fact. And that is using the logical form also is using a contrapositive. And that's a little bit about an indirect proof.